wanted to take a moment and make sure that you understood what you saw in the last video and show you some other cases where you have to kind of think through the numbers that you're working with, and sometimes it gets confusing about knowing which way to move your decimal based on whether you're moving it from scientific notation to standard form or vice versa, especially if it's already in somewhat of a scientific notation form. And this is going to be important when you move into task 2, when you're multiplying and dividing with numbers in scientific notation. So this worksheet is available on your Google Classroom. You do not have to print it out. I would suggest just getting a piece of paper and write things down with me, and then you'll have a few to do on your own. So we're actually just going to start with number 1. This is obviously standard form because there is no times 10 to the power of anything. So I know I have to get my decimal behind the first non-zero digit so that my number in scientific notation, that leading coefficient factor, is 1 or more, but also less than 10. So I know my decimal is going to have to move to behind the 6. To get there, I'm going 1, 2, 3, 4, 5, 6 units to the right. So I'm going to have 6 times 10 to the 6. But because it's a small number, you're going to be doing it as a negative 6. When you're thinking about it in terms of scientific notation, it's like dividing by 6 every time you move to the left. So we have to get it back to standard form. That negative says we got to make our number smaller. We're also going to look at number 3. 60. So there is no decimal written here, but we know if there's no decimal, it can just fall straight at the end. And we actually only have to swoop it 1 full time. So we're making the number smaller. So really this is like saying 60 times 1/10 because we are swooping it once to the left. So remember from our exponent rules that this is just 10 to the negative 1. So when we move it over, it would be 6 times 10 to the negative 1. You could put the 0.0, 6.0, but it's really not crucial. We're going to go straight down. We're going to go to number 5. So this one's a little weird because we know in scientific notation that leading factor has to be 1 or more, but less than 10. And it already is. So we can just write 6.7, but we do need to have that times 10 for it to be in proper scientific notation form. So what's the only thing we can multiply any number by and not change its value? 1. So if you think about what exponent would my 10 have to equal 1, and hopefully you remember, with an exponent of 0, that base becomes a 1. We're going to keep moving down the line. Number 7, without my decimal, that's hard to read, or sorry, without my commas, but that is 2 million. So 2 million, we have a large number, so hopefully at this point you're starting to realize, okay, my exponent is going to be positive because I'm working with a large number. And then it's pretty easy to see the decimal is going to have to go behind the 2 because there's no other numbers behind it, and that number is greater than 1 but less than 10. So 2 times 10 to the, and every comma we know is a group of 3, so 1, 2, 3, 4, 5, 6. So if I was having to move it back to 2 million in standard form, that positive exponent would make me move to the right. For number 8, so this is one where you really need to kind of think through it different ways, and different teachers will teach this different ways. You have to figure out what works for you. But this is how I think about it. So I have 71, there's my decimal, times 10 to the positive 3. Scientific notation means that my number has to be 1 or more, but less than 10. I'm obviously not less than 10, so I'm going to have to make my decimal swoop to the left. And that's where kids start to get so confused. Is it, okay, so I've made it smaller, what do I do? If I've moved it left, doesn't that make it, it just gets confusing. So here's what I say. You have made this number smaller. You've made it smaller by a factor of 10, but you want it to be equal to the number 71 times 10 to the third. These are equivalent values, you're just representing them in different ways. So since you've made this smaller by dividing by a factor of 10, you've got to give that factor of 10 back to the base 10. So it's times 10 to the fourth. And then we're going to look at number 12. So this is a very similar situation. It appears to be in scientific notation, but it's not completely done because 33 is greater than 10. So I know my decimal is going to have to move somewhere. And hopefully you recognize I need to move it to the left. So again, in this case, what have I done? I've made my number smaller by a factor of 10. So in order to keep it equivalent, I have to just give that factor of 10 back. So it's going to become 3.3 times 10 to the, and then you add your exponents, negative 2. I would like you to go back up and try number 6, write that in scientific notation. Now I would like you to complete number 9 and put that in scientific notation. We're going to look real quick going from scientific notation to standard form. The one thing I don't like about their directions, and really honestly they didn't even say this, but looking at number 17, is that proper scientific notation? And hopefully you're saying, nope, sure isn't, but really it wouldn't matter. So for 17, that negative 1 exponent. So this is where, again, it gets confusing. Am I moving it left? Am I moving it right? And I get confused even as a teacher of this stuff. How am I supposed to move it left or right? I get all those rules mixed up. So the way I think about it is, well, there's one of two ways. Some teachers will say just to write that as 1 over 10. So it's a tenth of the number. So if you're taking a tenth of something, it's getting smaller. It's the same thing as dividing by 10. So if you're dividing by 10, your decimal is going to swoop over once to the left. So 0.09. We really should add that leading 0 before the decimal. It doesn't change its value, but that's the best form to write it in. We're actually going to skip all the way down to number 25. I have 9.5 times 10 to the 7th power. So you could write times 10 times 10 times 10 7 times. Hopefully you're recognizing, well, hey, if I'm multiplying it by 10 7 times, it's going to be pretty big. Positive exponent typically means a big number. So I'm going to have to scoot it over 7 times. If you did scientific notation in elementary school, your teacher probably taught it to you as, oh, just add 7 zeros. But, as you get to upper math classes, they do have digits behind the decimal that you have to account for. So you are literally moving the decimal 7 times. I find that it's much easier if you just rewrite it. So there's my 1 swoop, 2, 3, 4, 5, 6, 7. Hopefully you recognize that you're going to be adding 6 zeros because the first swoop had to get beyond the 5. Don't just leave it like that where it's really messy. Go ahead and rewrite it. You can put the decimal at the end if you wish. Get those commas in there. It makes it really easy to check if you needed to. And then we're going to look at number 29. Similar situation. It's proper scientific notation form at the moment, but I got to get it to standard form. Standard form is the numbers that we're used to, or the form of the number we're used to seeing. Negative exponent, small number. Just take a second and rewrite it, and then move that decimal 5 times. I'm dividing by 10 5 times. 1, 2, 3, 4, 5. And notice that it's not 5 zeros, it's only 4 zeros, so don't let that confuse you. Take a moment and complete number 31. Take a moment and complete 32.